Yes, hello everyone, and welcome to our discussion for Book 1, Proposition 20 of Euclid's Elements. Proposition 20, if any triangle, the sum of any two sides is greater than the remaining one. It is also known as a triangle inequality theorem. So it's basically telling us that the sum of two sides of a triangle is always greater than the third side, never equal and never less than. Okay, and to show consistency for that proposition, here's our figure here. And to build it, first we're going to have triangle ABC here, and then extend line AB to point B, and connect two points AB, okay, to form line AB. And to determine the length of line AB, we will replicate line AC and make it equal to line AB. So we have the equation AC equal to AB. Okay, and with that, we have formed a triangle ACB here. Okay, and to show consistency to the proposition, here are the components of our proof. So again, we have extended the line, replicated the line, and drawn a line from 2 points. And we also have the isosceles parameter that the angles of the base are equal when it has been extended with lines of equal length, of equal sides, And then we'll be making use of common notion that the whole is greater than its parts. Okay? And lastly, proposition 19 or proposition 18, which show the direct proportionality of angle and of the sides opposite to it. So let's now discuss the proof. So first of all, we have AD equal to AC. So let's take note then that the angles opposite to those sides will share the same equality. So we have angle ADC here equal to angle ACD. This one, okay? And please take note that ACD is just a part of the bigger angle BCD here. And since the whole is greater than its part, then we can say that angle BCD is greater than angle ACD. Okay. And since angle ACD and angle ADC are equal to each other, then we can also say, substitute, replace angle ACD with ADC. We can say that angle BCD is also greater than angle ADC here. And it just so happened that ADC as an angle is opposite to the side BC. And the angle BCD is the angle opposite to a big line BD. So we can say then that BD is greater than side BC. Now let's break down the side BD. We can see here that the side BD is equal to line or side AB plus side AD. So in other words, we have the equation BD is equal to AB plus AD. And since AD is equal to AC, then we can also say that BD is equal to AB plus AC. We replace AD with AC. So BD is equal to AB plus AC. And yes, that already gives a scenario or an example of having or adding two sides of a triangle. So we have AB plus AC equal to AB plus AD. Okay, and since BD is greater than BC, okay, then we can have the inequality that states AB plus AC is greater than the side BC. So that concludes our discussion of Proposition 20. Thank you so much for watching and listening, and stay safe.